Hey guys, welcome. In this video I would like to show you how you can write and deploy smart contracts in Solidity using Remix IDE. Remix IDE is basically web application, so all you have to do in order to write your very first smart contract in Solidity, all you need is your browser. And then inside your browser, just go to remix.ethereum.org and then you would see this beautiful IDE. So here you have a workspace. Here is a regular editor where you can create new files, new folders, and just write your Solidity code. Of course, I'm not telling you the Remix IDE is the best option to write smart contracts for production, because then usually you need to write some tests and you need some orchestration of your smart contracts. So you need migrations, and then you can use tools like Truffle, Open Zeppelin, or Hardhat. However, here is, I think, a great environment just to try out a Solidity, especially that you can easily deploy your smart contracts to the testnet, to the mainnet, and then you can just try to test and verify your smart contracts within this environment. So, okay, first of all, I'm gonna create a new file, the very first smart contract. And the smart contract, I will call it fee collector, because this would be the smart contract that basically is able to take money, and the owner of the smart contract can withdraw that money. So we're gonna create a very simple smart contract just to show you how easily you can create the smart contracts. So first of all, if we are creating the contract, we are using here the Solidity language. Solidity is a special language that you can use for preparing smart contracts and the Ethereum virtual machine. Solidity is an object-oriented high-level language, and I think it's quite similar to C++ and maybe JavaScript. So if you are familiar with these languages, I think you should not have any problems. In the description to this video, you can find some free resources from which you can learn the basics of the Solidity, because in my video today, I would like to just quickly show you how you can start writing contracts and how you can interacting with them from the Remix IDE. However, if you need the basics of the Solidity, like how write functions, what types are inside the Solidity, I think you can find everything here in this official docs. So whenever we are creating a contract, we have to name the contract. So this contract would be named fee collector, and of course we have to open the body of the contract. However, before we write any code, we have to always specify what version of Solidity we want to use. So we need to basically specify this in our code, in every file that has the smart contract code inside. We have to specify this just to inform the compiler what version of Solidity actually we are using. So we are having here Pragma Solidity, and we are using the latest version. Of course, if you are watching this video in the future, probably you might change the version of this Solidity here in the compiler section. So this is the second item on the menu, and here you see all the versions of the Solidity compilers. And I think it's, especially if you are experimenting, if you want to try something, it's I think advised to check always the latest version of the Solidity, because you have the access to the latest feature in your in the Solidity. Of course, for some legacy applications, you might need to choose other version, because you might use some of the features of the language that were deprecated. But of course, we're gonna use the latest version. And okay, we have our smart contract here, and right now we're gonna create a constructor. So whenever we are deploying the smart contract to the network, then for the first time, the constructor can be called. So it's the special function which is called whenever the smart contract is created. And of course, like in any other languages, we can pass parameters to the constructor, or we can just leave the constructor without any parameters. And we can write here some code that would be invoked whenever the smart contract is actually deployed to the blockchain network. And here I will just write in the constructor, I will save information inside the smart contract about the owner of this smart contract. So basically I want to have the variable which I will call the owner. So this is the special variable which will hold information about who is the owner of the smart contract. And Solidity is typed language, so if I want to keep any information inside this variable, I have to specify what is the type of this specific variable. And in the blockchain world, in the Solidity, the ownership is represented by the public address. So we are not dealing here with some API keys. We are not dealing here with JSON web tokens. In the blockchain world, if you are calling the smart contract, if you are deploying the smart contract, if you're reading from it, or if you are issuing some transactions or calling the functions from the smart contract, you always operate with your address. So we're gonna store the address of the owner of that smart contract. So we have to specify the type of this variable to address, and we're gonna mark the variable as public. So you see here that whenever you want to specify the variable, you have to specify the type of this variable, and you have to specify the visibility of that specific variable. Of course, you can read all the details of that stuff in the official docs of the Solidity, but here we have the really simple variable, which is the address public owner. And here in the constructor, we're gonna assign that the owner is the message.sender. And message.sender is a special variable in this Solidity world. So whenever somebody is calling the function, then under message.sender, we're gonna see the public address of the caller. So let's say I'm gonna deploy this smart contract, this fee collector with this account, then the message sender would be actually my public address. So that would be under the message sender, and I'm assigning this value under the variable called owner. So right now we have a really simple smart contract that all it does is actually creates the smart contracts and assigns the owner under this variable. So let's try to actually compile this specific file. We have one warning about not specifying the license of our smart contract. So just to shut out the compiler, I will copy here the information about the license. So this is MIT, and now you can see that we can click on the compile the fee collector. We can even click here auto compile. So whenever we change it and save it, then it would be automatically recompiled for us. So right now we have this smart contract, and I think it's the perfect moment to actually deploy it. And here, if we go to the next section of the Remix IDE, here we have the interesting options in which we can deploy and run our transactions. And here you have the environment. One environment is JavaScript virtual machine. So this means that we are able to deploy our smart contract not into the real blockchain network, but we can deploy our code into the JavaScript memory. So basically in this memory of the browser, we have the simple version of the blockchain to which we can deploy the smart contract. And of course, you may ask the question, why the hell we need that, right? Why we need to deploy something into the memory? It doesn't make sense, right? But it turns out that if you want to try your code, or just to be sure that your code is working before actually deploying the code to the real blockchain network, you can deploy it to the memory, because then it's much faster. So you can just check that, okay, the logic works, and once you are sure that everything is fine, then you can deploy it to the testnet or even to the mainnet. So here we have this environment, which is a virtual machine. We have here various accounts. So right now I can choose the account which I'm interacting with the virtual machine. So this actually is something like I would use my MetaMask, my wallet, but here I'm just using some test wallets that are connected to the virtual machine. And right now let's click the deploy. And if we click the deploy, now you can see the list of deployed contracts. And here basically we have just one thing that we can call on this smart contract, because automatically if we have the public variable, then we have a reader to that public variable. So if I click the owner, now you can see that this is the address of the person which actually deployed the smart contract. So for instance, if I change the account and if I click the deploy again, now you see that we have two instances of this contract deployed, and the second instance, if I call the owner, you actually see that the address here is completely different than in the previous case. So we have two instances of our contract deployed. So of course now our contract is actually not that interesting, right? We have just a constructor, but I think it would be great if we can send the money to this specific smart contract. So in order to send the money to the smart contract, we have to prepare the special function which is called receive. So whenever we want to write logic for our contract that is able to receive some money, then we have to create the function called receive, and we need to mark this function with the payable keyword, and then we have to also turn the visibility of that function as external. And for instance, right now, if we have the function receive, it's possible to send actually the Ether to that smart contract, because whenever we are deploying the smart contract, you can see that we have the address of the smart contract. So this smart contract is deployed under this address. Of course, this address is not real because it lives only in the JavaScript virtual machine. However, we will now deploy our smart contract into the Rinkeby test network. So you would see that we can also use very easily the IDE to deploy the smart contract into the testnet. So the smart contract has the address, and we are able to send the money. So this smart contract will hold the money. And here we have the function called receive, and this function would be called whenever somebody sends money to the smart contract. And right now, I think it would be great if we can not only store the public value, which is the owner, but we can also store another value, which would be the balance. So right now, I want to have the public variable that store information about the balance. So whenever the fee collector smart contract receives money, we're gonna increase the balance so we can track how much money is actually stored inside the contract. So right now we have to add a type for this variable, and we want to keep it as an integer. So I will use the unsigned integer 256, and I will mark this variable also as the public one. And right now, when we have the variable called balance, we can here just type balance plus equal message value. This is equivalent to something like balance plus message value, right? So you might know this from JavaScript or other programming languages, that we are just increasing the balance. So the function receive can be called twice or 5 times, and whenever we receive the transfer into that contract, we just want to increase the balance, and we need to know, so we can know how much money is inside the contract. So message.value is another special variable in the Solidity, which basically lets us access how much money was sent to the smart contract within the transaction. So if somebody is calling the function, the message sender is always the person which calls, so basically is the address. And whenever we are sending some money, the message.value holds information about how much Ether was sent to the smart contract, and it's represented in way. And we can save that smart contract. However, this time we're gonna deploy it into the Ringkey test network. So if I select here the injected Web3, then the Remix IDE is connecting to my MetaMask wallet. So right now I'm using the account 1 on the Ringkey test network, and here you can see that Remix IDE is connected to my wallet. If you are doing this for the first time and you select the injected Web3 and you have the MetaMask, then MetaMask will ask you about connecting into the Remix Ethereum org. So you might accept this whenever you want it. So here we have the account, the one from the MetaMask, and now if we want to deploy this smart contract, if I click here the deploy, now you can see that MetaMask asks me about issuing the transaction. So if I will confirm it, then we are deploying our very first smart contract in Solidity into the Ringkey test network. And after some time, you see that we actually deployed the smart contract. So we have the smart contract, we can call the balance is 0, and here you can see that the owner of the smart contract is actually the caller. So I'm the owner because here is obviously my current address. And here, if we copy the address of the smart contract, and if we go, then you can see that it's our smart contract. So this smart contract is basically deployed to the blockchain. You can see that our code was compiled into that code that is not really readable to humans, and now our smart contract is here on the blockchain, and now we can start calling it. So now I will send money to this address. So this is the address of the smart contract. And if I go into my Ringkey, I can just here type the recipient, and here I can decide that I want to send, for instance, 0.02 ETH. And if I select and I have the contract interaction, if I click the confirm, now I send just 0.02 ETH into that contract. So let's see the block explorer, and here we see that we actually have the balance. So our transaction just arrived to the smart contract, and if we call the balance here again, now you can see that actually the money was received. However, our smart contract is not ideal because we have some money inside the smart contract, but smart contract only knows how to receive money, and there's no option to get this money back because this specific smart contract only receives money, and we deploy it, and now we are not able to change the code of this smart contract. So let's fix it and let's deploy it again. So this time we're gonna create the function which gonna call withdraw. So I will use the keyword function and withdraw, and this function will basically take the parameter, so we can take how much we want to withdraw, and then we also want to specify to which address we want to withdraw this money. So we're gonna have to type the type address payable, because we need the type of the address to which we can send the money, and we can type here test address. So here you can see that we have the function, and the function is called withdraw, and it takes two parameters. One is amount, and second is the address destination address. So this function, whenever it's called, we want actually to transfer money to this address. And every address, every payable address in the Solidity actually has the function which is called just transfer. So we can just specify here the amount that we want to transfer from our smart contract. So basically we will call this function with two parameters. One is how much money we want to withdraw, and the second is to which address we want to send it. And of course, whenever we do the transfer, we of course have to deduce it from the balance. So balance is always representing the correct amount. So from the balance we have to deduct the amount, and compiler is shouting that we have to mark the function how it should be visible. So whenever we want to have the function that can be called outside from, so anyone can call it, we need to have the visibility set to public. So right now this function is public and everybody can call it. And you might be surprised that why we have the function that everybody can use, because as you can see, the smart contract collects money, so it holds 0.02, and then we have the public function which anybody can call. So this can result with the stuff that anybody can come into my smart contract, and just by knowing the smart contract address and the ABI code, which I will cover in separate video, then you can just start interacting with this smart contract and everybody can withdraw the funds. So I guess we have to secure this function a bit. So this function and this transfer can occur only if this function would be called with owner account. So this would be the special function that of course is public, but it can be called only by the owner. So there is a nice solution for that. We can write require, and this require is checking basically the first parameter is checking whether it's true or false. So we can write here that the message sender has to be owner, and if it would be false, then we want to return the error, which would be only owner can withdraw. So right now we have the guard that function would be called, and here the Solidity will check that the message sender, so basically person or address that calls the function, is equal to owner. And if this would be not equal owner, then it would be false, and it would be this error raised, and all the other execution of the smart contract is stopped. So require is a really nice function which let us do some sanity checks inside the functions, just that we are sure that the function can be called. And another, I think, useful thing that we can check in this function would be that this amount is lesser or equal balance, just to not have situation that the balance is 0.02 Ether and somebody wants to withdraw 2 Ethers, because obviously it was result in some error. So we're gonna check it, and we're gonna present to the user nice error like insufficient funds. So right now I will save this smart contract. It's gonna be compiled, and now we're gonna deploy it again to our Rinkeby test network. And you can see that whenever I change the code, I'm not able to use the old address. See that old smart contract is already deployed, and I'm not able to change the code of this smart contract. So here I will deploy another one. So if I click the deploy, then MetaMask again is asking me about the transaction fee, because of course I have to pay to the miners that they will mine my transaction, and I have to pay the fee for actually putting my smart contract into the blockchain. So this transaction fee depends on the size of your smart contract and how heavily are you using the memory. So the bigger the smart contract is, the more variables you are using, the more memory you are using, you will pay more transaction fee. So right now I will confirm that, and in the minute we need to we would see the second instance of this fee collector smart contract. So right now you see that we have the withdraw function which takes some arguments. So again I will copy it and I will send some money to this smart contract. So let's specify, and let's send 0.03 if to this smart contract, and we're gonna confirm that, and let's wait a second for the transaction to be actually mined. And now we see that the balance actually updated, and now I will try to withdraw the funds. I will specify that I want to withdraw not all this amount, so I will just maybe try to withdraw one, so 0.01, and I would like to send it to some other address. So for instance, we have here some address that holds 0 ETH, and I will just specify here the address. So I'm providing this as an argument, and I will call a withdraw function. You can see that we have the error because the only owner can withdraw. And the reason why we have it is that in the MetaMask right now I have this account 7. And if I go to the previous account, the one which is the owner, right? Because we have the owner here and we are checking it. So if I click the withdraw again, now you can see that transaction works. So our require actually worked and checked that we are the senders. And if I click here now, the confirm, now we have the transaction in the blockchain to be mined. We have to wait a second, and the balance should be updated shortly. So you can see that right now it holds 0.02 ETH. So it's no longer 0.03. If we refresh that this smart contract holds 0.02. And if we check my account that previously had 0 ETH, now we can see that it holds 0.01. So that was just to show you how you can develop smart contracts. Of course, this is just an experiment. If you want to create the smart contract that does way more things, it's also possible. You can, for instance, emit events from the functions. You can write some private functions that are just accessible from within the code of the smart contract, so they cannot be called publicly by anyone. So there are a lot of interesting topics that of course you can do with the smart contracts. However, here you can see how powerful it is, because you can just deploy the smart contract once, it goes to the blockchain, and then you can write a logic that is responsible for taking the money and proxying it to some other addresses. Of course, you can here also add the list of the people that are whitelisted in order to withdraw the funds. So you can use the one single smart contract and do a lot of interesting use cases. I hope you liked the video. I hope you learned something new. Of course, if you have some more questions about Solidity and smart contracts, post them down below in the comments section. I know that I didn't cover everything about the Solidity, but I just wanted to show you how the constructor works, how the Remix IDE works, how you can deploy the smart contracts, how you can choose the environments and do the compilation. And then, of course, in the upcoming videos, I will show you how you can deploy the smart contracts and then start interacting with them from the React.js applications. So that's all what I have for you. Thanks for your attention and see you on this channel.